Alright, so I'm going to talk about web views controllers and view controllers. Next week we'll go through the calculator program because I have the wrong file with me today and I don't want to go spend it. It'll take me about 20 minutes probably to look for it. Because I have it on a different computer, it's not online unfortunately. So what I'm going to do today is skip gears, go back to view controllers. So what we looked at last time is I went over a brief kind of a recap of Objective-C to give you the kind of fill in the blanks after we've looked at this for a while, because I did it in the beginning of the course and I wanted to refresh your memories towards the end of the course. And what I did the time before was I actually started going through the navigational stuff, the views, the list boxes, and all the GUI components. So this is actually a continuation of 2 weeks ago. So we had that break for Objective-C in between. So today what I want to do is kind of pick up where I left off 2 weeks ago, if you can think back that far. And what I was doing then was I was talking about the object lifecycle, the program app lifecycle, as well as the controlling aspects of it. So the view controller lifecycle is one of the components to consider in terms of, from a programmer's perspective, the application in terms of how it's going to function. The view controller itself has a lifecycle to it. What is a lifecycle? It's a sequence of messages is sent to them as they process, as progress goes through. Things happen, the controllers come into focus, out of focus. They also essentially end up being used for certain purposes and then discarded or garbage collected manually, allocated and deallocated. So what does it really matter in terms of the sequences of messages that are sent to them? Very commonly override the messages themselves and do certain work for the controller. Going back to the concept of the view controller, it's sort of part of the model view controller perspective in terms of the design pattern for, which basically is the Apple design pattern in terms of the features of the view being the screen, the model itself being the data, the persistent part of it, and then the controller, which is the navigation part, or it's more than just the navigation, however, it's the control of the view using the data. So we talked about the first part of the life cycle in terms of the creation, and that's what I covered actually, because this is a continuation of it. That's what I covered 2 weeks ago, is when we were talking in terms of the this particular lecture series when I was covering the UI components and the creation of the application. Mostly done via storyboards, SIG views, all sorts of different things, instance view controllers themselves with identifiers. In terms of the view controller, after the initialization, instantiation, and the outlet setting, we have the view did load, which is called, actually says, upon the completion of the loading, we have this method, the view did load, that is called. And on this particular method, this is an example of what it looks like. Void is the return value for it. View did load is the instant method of the instance. And is an exceptionally good place to put code, lots of different setup code. Because if it loaded, we have to load the functionality for the control that's going to happen. And so in terms of the view controller, we have to be careful because of the geometry of the view, its bounds has not been set yet. It's still the beginning of the instance of the creation of the app, or of the running program, of the thread. So you need to initialize something based on the geometry of the view. Also, you're going to use the next method. The next method comes later. So in terms of the life cycle of the view controller, we have the initialization of it, the load, and then we have the after the load, and then we have the while it's running, and then we have the shutdown while it's gone out of in terms of not being used. The first part of it's relevant because first part of the life cycle is when we're interested in actually controlling the behavior. The end, we just need to clean it up. We just need to deallocate it. So it's not necessarily a huge concern in terms of application design. So just before the view appears on the screen, you get notified. And so the thread comes back and says, well, we have a view will appear, which is a Boolean, in terms of the return type that's associated with animated. Is it on or off? Are we gonna have something? Is it gonna? And most of the apps that you're creating are going to be using built-in methods for animation to a certain point, especially if you're trying to add those special effects for things swerving to the left, swerving to the right, doing sorts of things. So when it's called, your bounds have been set. at this particular point. You know which part of the screen the particular view is appearing. You know essentially the coordinates. You also know the controls that are associated with it. So via your frame, your super view, whatever it is that you actually happen to be loading it from. So your view will probably only get loaded once, usually, at the beginning of the application cycle. And it might appear and disappear a lot. It only gets loaded this particular method only in this particular here, on the view did load and on the view will appear, only happens once in the life cycle. It happens in the beginning of the life cycle. After the view appears, it doesn't go away. It stays around, which is kind of different than the Android thought actually, because on the Android system, it loads, it unloads, it loads, it unloads. It's constantly using an intent back and forth. Here it's a little bit different because now we can capture not only the loading, but the after the loading and all of the other intermediate steps that were associated with it. So when the view will only get loaded once, so you can put something, you don't want to put something in the method that you really want to have in the view did load. So on the view did load happens more than once, and it will appear, it only appears once. So otherwise you might be doing something over and over again. It's unnecessary if you put too much in here. So the design of these particular methods is basically to set initialized behavior, set parameters, set information. That's only going to happen essentially when something loads. So you could use this to optimize performance as an example, set colors, set screen size, listen for events, waiting for a particular method to occur just before the view appears. So to kick off an expensive operation, you might want to put it in a spinning loading icon or something like that, so that you can kind of see a long-term effect happen. And in summary, this method is a geometry-related initialization and lazy execution for performance. So it's not given a high priority thread. It's actually kind of not very optimal. It's just something that happens in the background in terms of the functionality. Something I'm talking about is the functionality that you're writing in terms of when the method actually gets called. So you get notified when it disappears off the screen as well. So in terms of the life cycle of the view, we have the loading, the showing, it's gone, it's invisible. So we can unload things, we can reinitialize things, we do garbage collection. We don't want to do too much garbage collection because it's not gone, it's just not showing, it's not visible anymore. So what we have then here is the method that says view will disappear. So when the view disappears, we can animate something. So we can, set the animation to the window to do interesting effects or something, or we could turn that off if we wanted to. So this is when you want to remember what's going on, or cleanup code, essentially, because next time it loads, you want to make sure certain things are selected or certain things are kind of set. So it's semi-cleanup, but you're expecting it to load again, or you're expecting to have to save that information. So in terms of the view will disappear method itself, it's called by super, and the view will or did appear methods. So it lets you essentially put in scroll positions and things to save information about the GUI itself. And we have member scroll position, we have save data to permanent storage and other things that we can actually kind of do to kind of automate the process. So there are did versions of both of these two methods. So the view did appear, the view did disappear. So the view will appear, it did appear, meaning it actually as it did. So basically it allows you to catch all of the different steps in the view appearance. We also have ones to look for and to see if other events have occurred, such as the frame changed. So here's a good place to lay out subviews manually to include different things, strings, a bunch of other stuff. Are they essentially called when a particular frame changed? So called on the views frame change for subviews and things. So you can relay out the interface if you need to. Also for auto rotation and things, if your view was set in a landscape mode on this particular, did it actually change on the will or the did version of the method? You could probably set one or the other for something in terms of the auto rotation or something, because you're not going to do it twice. And just think this actually with the code that you're putting into these sets of methods that happen on the load, and the check of the load are going to slow down the processing of the load because it's going to wait and it's going to give you a slower appearance, so you don't want to put too memory intensive activities in this particular area. So called anytime the view's frame is changed. We see the subviews and other things that are going on as an example for the auto rotation. You can reset the frames for the subviews, having a relay out your calculator or something of that nature. There's also, well, this is assuming I've gone over the calculator program, but I haven't done it yet, so getting there next week. We'll do the calculator program. So specific notifications and that rotate, or that rotation will, or that did happen. Did we get a notification? Did we rotate? Keeping essential track of that information. We have methods that will rotate to interface orientation. You know, how long will it take to rotate? We can set a duration for slow animation. We'll animate the rotation to an interface orientation as well. So we can set the duration of that as well. And I did rotate from interface. Did it actually occur? So in terms of the view controller lifecycle, the point to get across and to remember is that you can actually, throughout the entire life cycle of the action or the activity that's appearing, you can catch each one of the beginning stages and the middle stages is caught by the application, by the view controller itself, and then you get the end application. And the end part of it is nothing more than the unload or the disappearance in that particular case. So long story short, you can actually get the will, the did, the is going to, has disappeared, and is now terminated kind of activity for the entire life cycle. Property is going to have current orientation associated with them if they're going to be called above. So example, do anything expensive, an animation method in the will, and then resume it in the did. So you can split out the animation to make it so that it prepares for things that are memory intensive ahead of time, so that the, will something happen? Well, before it's actually happened, perform your expensive operation, or expensive operations going to be memory intensive in terms of what's going on. So in terms of the view controller itself, in low memory situations, the view did unload gets called. Why we're going to do that? Because the operating system itself is going to sense, it doesn't actually have automatic garbage collection, but it does know and it does sense how the memory is actually being used. And when something does happen, then it's going to unload things that are not active. And it does what's called memory swapping. So it will unload an app that's actually running, or a piece of your, will unload screens, views of your app that are disappeared, that aren't active, in hopes of making it making room available. So on a view did unload, when it gets called after the UI view controller's self.view is set to nil, so hopefully freeing up its heap usage, which is its memory. It can only happen if the model view controller is not on screen, of course. If it's on screen, it's never going to unload something. Instead, it's just going to run slowly because it can't unload it. So this rarely happens, but well-designed code will anticipate it. So, if you run most of 99.9% of the apps that you'll create, you're not going to run into memory issues, especially if you're using normal things. But if you're opening up a huge file and running with graphics and things, you've got 5 different videos running simultaneously, I could see where an unload might actually happen automatically to free up memory. When it's going to happen is sort of unpredictable. It depends upon what resources are being used and how much memory you have left. And it's up to the kernel level I shouldn't call it a kernel, but it really is a kind of a microkernel to figure that out in terms of the runtime. So it's a good practice to set them all to nil, so it can predictable. So nil will do the unload. So it's predictable nil when unloaded. So it kind of makes it a little bit more stable in terms of being able to set things. It's kind of like good practice. You don't actually have to. So here's an example here for our happiness view controllers. View did unload should probably look something like this to set self.faceView is equal to nil. So just in case the face view was actually called, the face view would be a view screen, something that appeared that actually it's part of the controller. So if you set it to nil, essentially you're going to guarantee that it's kind of like setting a pointer to null. You're guaranteed you're going to figure out, it's not loaded, so it has to be loaded again. So if the UI controller goes back on screen, the view did controller, etc., will be called again. So, which is kind of interesting. So if it did unload something and the view did unload, actually returns successfully, then it knows it has to load it. So it's a nice way of swapping out components or automatically having components swapped out for you on a low memory usage. So in terms of the initialization, when you're creating the UI controller from the XIB file itself, this is kind of the old iOS 4 way of doing things. Not covered in this class. Actually, it's not covered in most of it's not going to be covered anymore. It's a very old way of doing something. So when you create the XIB file, the same name as XIB controller class is used, and we have the alloc and the init to create one. So designate initializers themselves only if needed to overwrite it using an init otherwise. So we have the init mode actually that we're going to use now. So init with no. So creating a UI controller UI in the code, there's no XIB in the storyboard. Actually, we don't have the storyboard in actually current configurations, or upcoming, I should say, not really current. So overriding the method, the load view with the self.view is something that's actually done. So there's neither nor on the storyboard or the XIBs. So do not implement load view if you use a storyboard .xib file to create it, because then you've done it twice. You have twice as much work happening simultaneously, and what ends up happening is the systems will it'll work, it just runs slowly. And do not set this self view anywhere else because of the load view. In fact, what can end up happening is creating a loop of events, and the thing will never load anyway. Just keep loading, performing checks back and forth. And don't implement the load view without setting the self view, i.e. you must set the self view in the load view. Otherwise it doesn't know which self. It doesn't identify the view. Self doesn't identify the view. So also avoid awake from nib if possible. So it's an acceptable place to initialize stuff, the UIWebView controller from the storyboard XIB. But try to put the stuff in the view did load, and the view will appear on the same preparation code instead. So basically you're just taking it from one port of the code, from the awake from nib, which is actually not used anymore. It's from an older API. It's being phased out. And you're putting it instead into the view did load, and the view will appear methods instead, which more stable, more predictable. So in terms of the UI frames, UIView's frame, and the setting that, who's responsible for setting the UIView's frame? The answer is the object that puts the UIView to the view hierarchy. And I believe 2 weeks ago when I was covering the views, I was covering the hierarchies associated with them. And so if you don't remember that, go back a couple weeks actually. I'll hit that. In terms of the hierarchy, whoever loads it, essentially who's ever up as a super to the current view is responsible for the frame. They create the frame. So in the interface builder, you set all the views frames graphically by dragging and dropping, putting things over. See this by dragging on the little handles, and actually loads the frames. So what about the frames? Frame that's passed to the init with frames method. Well, that one's going to get loaded automatically. So if you're putting it into the view hierarchy right away, pick the appropriate frame and it will be associated. And if not, then it doesn't really matter what frame you choose. But avoid CG rect 0 because it'll actually put nothing on the screen for you. The code will eventually does put into the view hierarchy, but it will set the frame itself by default, whichever happens to be set in the appropriate order. So you're just making an assumption essentially when you create the hierarchy. So setting the frames in the view did load. Recall that the final bounds are set from the view did load and not after it loaded, not that it will load. So if you create the views in the code, in terms of the view did load, you pick the sensible frame based on the view's bounds then, if the bounds are set. If you haven't set the bounds yet, you can't pick the appropriate frame because you don't know the position. So, and be sure to put the correct springs and struts and things in there as well. So in the UIView's auto resize mask property is set correctly, which is where you're going to put the appropriate strings and struts. So think about adding something to the view did load as the same as laying it out in Xcode in terms of the interface builder. So in both cases, you're going to anticipate the top level bounds that's going to change associated with whatever you're putting inside of it. So, in terms of the UI image view, which is a different type of view, so what we've got here is the view concept in terms of the controller, starting with the frame, moving on to the concept of the image view. In terms of the image view, the UI subclass, which displays the UI image. We've seen that already, actually. We had one that put a bunch of images on the screen. So we covered that one. How to create the UI image. Well, actually, forget that comment there because that was covered in a different lecture. But actually, I didn't use this lecture for that. Instead, I did the one that showed pictures. It was one a couple of weeks came in here and we had a bunch, and I put it out on the YouTube site so you can actually see it. But there's one project that takes and loads pictures, like 5 or 6 different pictures, and flip it. So the animation is set, the view did load, the view will load, and then the image is corresponded to whatever image happens to be loaded in the resource directory that's associated with the view, and it's a UI image that is part of the view controller that's being controlled by the view. So how to set the view's image. UI image is essentially creating a tag that's going to associate the image with the resource. So you set the frame size to match the image size, hopefully. If you don't, you'll get a distorted image, actually. So that might be one of the causes if you've played around with that example yet and loaded, because I actually had a couple students do that, and they say, how come the images don't look good? It's because you have this itsy-bitsy little icon and you put it in this huge view, and you've set the size, the bounds to the size of the frame, and the image itself got stretched out. So the other choice you have is to turn off the stretching capability, and then you have an itsy-bitsy little image in the middle of a white frame or a black frame, depending upon how you have the black background set. In terms of the property here, we have the property non-atomic or strong, which will not adjust the frame size, so that the frame size of the image will look small inside of the image view instead of stretched out to the border of the image view in terms of the frame size. So remembering the UIWebview's content mode property, well, that was the one that was set to set the image itself. So the UI content mode redraw, left, right, scale, whatever, is the default kind of mode. In fact, most people would just stick with the defaults and not even set them. But you want to determine where the image appears in the bounds, in the UIView's bounds, and whether or not it's scaled, whichever the properties that you're setting. Bottom line, when you use the image view, it's important to make sure that you set the properties correctly for the image and use the right kind of image for the right kind of image view that you're going to set up. Otherwise, you end up with this distortion, or you end up with an effect that you don't necessarily want. Other features might be associated with highlighting the image, sequence of images forming an animation. Actually, you can use an image view for animation by rotating and using a duration or a timer to rotate the image, essentially. And so you've got flipping pages or flipping animation that occurs. Not the best way of creating an animated movie, however, it might actually be kind of interesting in terms of an effect. So. And which brings us to our example for today, and I'm going to show you what's called a UIWebView. I'm also going to show you the map view, because I don't believe I've shown you that yet either. So on the UIWebView, instead of the image view, which we've seen actually in the previous example, the web view would do exactly what you would think it does. It shows the internet. So full internet browser in a web view. So what we're going to do is build a project that's essentially going to take the canvas, put a web view on it, load Google or whatever we want in the web view. And it's a view controller concept where we have the the view did load, the view will load, and we have the garbage collection that happens on the other side of it, but it demonstrates the life cycle essentially. So you can use it not only to take your users to websites, but also to display PDFs, which is actually something different that you can't do on the iPhone, on the Android phone. So this actually works nicely on the iPhone, and we'll load a PDF file nicely. So you have some pros and cons to both platforms. It's built on the WebKit, which is an open source HTML rendering framework started by Apple. WebKit is actually a variation that's used also same type of API, which is actually used on the Android phone. So they're both compatible. They both have pretty much the same feature set. But in the Apple format, we have more support for different things, such as opening up files. In the Android application market, we have the downloading of the file, and then we have a separate app that's going to actually deal with the viewing and the manipulation of that file. So you might think it actually has better support on the iPhone part. Supporting a JavaScript, they'll both actually are compatible on the Android and also on the iPhone market. It's limited to 5 seconds or 10 megabytes of memory allocation. There is no limit on the Android part, but it is, the JavaScript usage is limited on the iPhone. It doesn't make it impossible, it just makes it, the iPhone itself is more conservative in terms of its use of memory, its monitoring of its activities. On the Android, it's easy to crash it because you can download a huge file, you can open up a bunch of things. There's no control over the usage of anything. In iPhone market, it's more control. The operating system itself is actually a little bit more solid in terms of its framework. However, it's more limited at the same time. Certain things are supported, certain things are not supported. It's a closed off, well, I shouldn't say it's a closed off, but it is a fairly closed environment compared to the Android operating system. It does support to a certain level, so 5 seconds or 10 megabytes of memory allocation. So you can't run heavy-duty JavaScript applications on the iPhone, long story short. But you can on the Android phone, which is interesting. Property to control whether the page is scaled to fit the UIWebView is also set. Same property exists actually. It's done in a little bit different way, but the same property exists on an Android. Where we have a scale to fit, if yes, the page will be squished or stretched, just like the images actually. It's the same property, but it's done on the UI view for the web view instead of the image view. If no, the page will be its natural size, and users can use the zoom controls to go in or to go out. Property to get the scale view it uses, well, we just ask for it. So we ask for the property of is the scroll view, to set the scroll view on it, to turn the scroll view on and off, we use the property that's associated with the scroll view. So you can set the property to have the left or right. If you're not rescaling it, you're going to have to scroll the page if the page is bigger than the window that it's actually setting in. 3 ways to upload to HTML. We have a load request, we have a load HTML string, a load data, which is actually kind of different than the Android application environment, which uses only one method. It's a load, or a load URL, or a load this or a load that. Here what we're doing is we're loading different types, and we're keeping track of the load request from different. In fact, the same thing might be true in terms of the view controllers as well. We only have one on or one off usually on the view. Looking at, in terms of the iPhone environment, we have all the different life cycles of the view itself that we can consider. So we have a lot more features in terms of the control over the view. In terms of the base URL, it's the same concept, loading a URL. So the base URL is the environment to load the resources out of. So we can set the base URL relative to the URL in the data itself, or in the HTML string. We can actually load an HTML file that's local from within the application, same way you can do in an Android environment. You can load data. It doesn't actually have to be an HTML file, which is the same case actually for the WebView component, because it's all based on WebKit. So because it's based on the same API, the same features are pretty much compatible. Which, if you're going to build a cross-mobile device compatible application, the WebView is really nice because it will give you cross-device compatibility for a lot of things. Mime, that's a pretty compatible standard as well. Type says how to interpret the passed-in data. If you're going to pass data in, multimedia, internet, mail extensions, all sorts of different things. Standard way of denoting file types themselves like PDFs. In fact, this is the same concept as you see in regular web interfaces. I think email attachment, that's named MIME, comes from actually, MIME is the email type, so is fully supported, long story short, in the WebView. NSURL request, everything comes from NSObject, so NSURL request, NSURL, NSURL request cache policy. We actually have these features on the Android, except for they're all done separately. So we can keep a cache, we can clear the cache on the WebView. On the Android, we do it all separately. On the iPhone, we do it all together. If we're going to do it all together, we have different methods to pick from for whichever operation we're interested in doing. As an example here, for the URL request versus the URL. The URL request itself make a request with the URL, set a cache policy, and you can also set the timeout for if the URL is not going to load at all, if there's something wrong, it's a bad URL or something. On the NS URL without the request version of it, it's basically the same thing, but like a string, you can enforce it to be well formed. So you're creating the URL, but you're not requesting the URL. So as an example might be a file, an HTTP. You're setting the, it must be well formed because it needs to know that it's actually an internet location. It has to actually say, is it a local file? Is it an internet file? This is actually different because the URLs on an Android environment can be anything. They don't have to be well formed. Well formed referring to including the HTTP : / versus file, because it doesn't know where it's going to be located from or where it's going to be loaded from. Because just like the Android WebView, you can load a local file, whether it be HTML or not. So it's intended for non-local if you think about the concept, because otherwise you just load that local file into a text view or something, a box or something. You wouldn't actually pick a web view for it unless you needed to load something from the file that was on the internet, like a piece of data or something. So the NSURL request cache policy, which can be set separately outside of the NSURL request. So ignore the local cache, ignore caches on the internet, use expired caches. These are all different options that you can set for the policy. Use caches only. Don't go out to the internet. Use caches only if validated, or valid. So maybe if it's out of date. So what does this mean? It's kind of like setting the cache on your web browser, giving you control over that. On the Android environment, you don't have all those policies you can set. You have a clear the cache if you want. Or keep the cache. Or clear the cache. Usually you're probably just going to clear the cache because it's going to take up room. It's going to take up unnecessary space. So we also have this other view, this scroll view, in terms of the scroll view. So that was basically, I'm going to show you in a few minutes. I'm going to go out and show you a Xcode example that I'll upload. You can take a look at it. In fact, all of the examples for this course are located in the examples directory that's in the vHacker website. Some of them I've included with the YouTube videos that I've been updating, but most of them that are of interest are actually in other examples. Those examples are going to help you, going back to those assignments I was talking about earlier, are going to help you with the assignments because they're all based upon the same kind of concepts. And as I mentioned, we're going to build the calculator next week. So here's our UI scroll view component, our next view on the agenda for today. So adding a submenu to a normal UI view, we would use a subview.frame is equal to something. Obviously here we have subview. This is from Stanford, so we have a little Stanford logo that shows up here. So add subview. Here's another one. It's a picture of the overhead of Stanford. So these are the open source Stanford iPhone lectures, PDFs actually, that they make available. So adding the subviews to the normal UI view, the subview itself would show up when you went to the higher level. You're nesting in the hierarchy. That's what you're doing. Adding a subviews to the normal UI view here, looking at add subview : subview, which is the same syntax. So we have it down here. It's going to end up as part of the subview. So you would set the bounds of the frame, where it ends up in the frame, whether it's going to stretch into the frame, fill the frame, whether this is going to be in its original view format. So you can actually take views in terms of the UI view and actually nest them. So you can put a web view inside of another UI view, inside of another UI view, essentially, and create kind of an interesting effect out of that, which is how you're going to get a menu bar or something that's, unique in terms of the interface. Adding subviews to UI scroll views themselves is also possible. Adding subviews to UI scroll views. And here we've got something here that's going to be put inside of a scroll view. These pictures don't really tell you very much. They're kind of basic pictures. Adding a subview to the UI scroll view itself here, looking at the code, setting the orientation so that the view itself shows a particular part of the view in terms of what it is you're loading, instead of showing you up the upper right-hand corner or the upper left-hand corner. So that you can get, this is probably the dimensions that you're setting for the mask to equal to frame size is going to be the frame size from the subview to the main view. So here we have different views that we can set given the coordinates of the subview that we're loading. You can actually do this with a web view as well. If you load a web view in terms of a scroll view inside, you can actually set it to show you the center, the left, right, the part. In fact, you can set without even doing any nesting at all. In the web view itself, you can set the orientation. Excuse me, not the orientation. You can set the frame boundaries to orient a certain part of the screen. And then you can also turn it off so you can't scroll it either, which is kind of an interesting effect. So adding subviews to the scroll views itself here, basically showing you this example with this picture that you're going to put in as the aerial view of the campus. You're going to stick it in different coordinates. You're going to load in there to get different areas. So this one's slightly different than that one. So, and that one's slightly different than the previous one. So, and that one's obviously a lot different than the previous one. All you're doing is changing the coordinates of the boundaries of the subview inside of the frame. So. All right, and the offset as well. Instead of setting the dimensions, in fact, these examples here are setting the dimensions of the frame by the coordinate system. Instead of setting the dimensions, you can just set the offset if it's easier for you, which is another technique that you can use. So you have the upper left off visibility is going to be equal to something with an offset. So the offset can be 5, 10, whatever it happens to be in terms of the number of how much space you want, essentially from left to right or top to down for your view. So you might not necessarily want the whole thing. So if you set it by offset, then you actually don't need to know the coordinates. It's a little bit easier, actually. So examples here are just showing you different offsets that are created for this particular view. So it puts different pieces of the picture inside of the frame. So. And what you're going to do is experiment around with it. You need this because maybe you want to do this for a picture or something that you're loading into a view. You want to set the offset, perhaps maybe to show just the left-hand corner or just the right-hand corner or something. In terms of the scroll view, how do you create one? Just like any other type of view, just like any other UI view. Drag one from the storyboard from the library, put it over onto the campus, on the canvas itself from the interface builder, and or select the UI view from the storyboard and choose the embed in scroll view from the editor menu if you wanted to. Or you can add to big UI view using a add subview. What you're going to do it programmatically. You're going to say UI image is going to be define the image and then define the UI image view, and then put the image inside of the view after you've assigned the image or some JPEG file or something that's associated with it. So, scrolling, you can actually set the scrolling programmatically. Some of this stuff is really dry, so I think I'm just going to kind of skip through some of this stuff. I will upload this so you can read through it at your own pace, but what I want to do is kind of just show you the examples. But setting scrolling programmatically, turning it on, turning it off, setting the image size programmatically is also possible. The indicators themselves, zooming in, zooming out. You'll see that with map views is a perfect example. You're probably going to want to zoom to a coordinate location. Basically, put the location in coordinates, longitude, latitude, and then set the zoom to a particular depth associated with that. Minimum maximum zoom can also be set so you can't zoom in too far, or you can't zoom out too far, also without setting things programmatically, or you can set it within the control itself so that when the zoom control, and we'll see the zoom control so when I get to the map example, can set certain parameters, or you can turn things on or turn things off essentially programmatically. So, and here what you're looking at is examples of different zoom scales. So this is 1.2 and 1.0, so you can sort of see. I don't really see much of a difference between that, but as you go down further, as we're zooming in on certain areas, we see only certain parts of the picture is actually going to be appearing. So, all right, so I believe I am close enough to the end here. I am. Okay, I'm close enough to the end to scrap this. And What I have here for you are two examples. Actually, one of them I put together a kind of a tutorial thing for it. Copied it from an example. In this particular case, it uses not a web view. Actually, it does use a web view, but not a map view. So, if you wanted to, you can download this particular file. I'll put it as a link to the video. And when you download it, what you're going to do is run through the steps here. And the steps are essentially going to show you. And basically, it's pretty easy. I'll just cut and paste. But it's going to demonstrate to you actually, this does use the map view. Let me just open it up actually to show it to you, rather than going through the steps for you. But you would create a new project, expand out the project, open up the interface builder, drag and drop a web view or a map view object, depending upon which example. And I have two of them that you can look at. Change the properties of the component programmatically, and then load it essentially. It's like one of the easiest programs out there on the market. This particular one is the WebView example, which I believe is going to be this one. So if I load the if it loads, that is, I'm sure it will load. Installing it, it's actually kind of running slow right now, so it'll load. I have faith. Oh, this is the map view. Okay, so on the map view, it's just basically showing you the world, the continent. It's actually not zooming into anything. If you click in the box in the view, the default controller is not actually set. So rather than having a GUI item to actually click on, what you're getting is just regular old click behavior. St. Helena's out there. So on a double click, it's actually zooming in. I don't even know what part of the country this is actually, but it's not even, no, it's not the US. So long story short, the example here brings up a map without any, it's just a basic bare bone without any parameter setting at all. And to show you the bare bone kind of implementation for it, what you're looking at is very similar to a hello world kind of scenario, in which wait for things to load here for a second. Alright, that's not going to load. Oh, it is loading in the background. Alright. Computer's running a bit slow. So I double-clicked on the XIB file to bring up the interface builder to show you what the how complicated this actually is. It's just one view. It's a map view iPhone controller. It's taking up the entire screen, which is the essential application. So it's basically initializing the map view, telling what to show there is what the code is going to do. And the code itself, if you take a look at it, is basically creating an IB outlet for the map view map, and taking the map view and in the .m file, that was the .h file, doing nothing more than doing some error checking on the did receive memory warning. If there was a memory warning, it's going to close. Otherwise, it's just going to load. And then when you unload it, it's going to deallocate, is what it's going to do, the cache memory that's being used. So it's used to actually kind of reinforce the concept of the view lifecycle, as an example from what I was talking about earlier. And here are the methods that I was talking about earlier. On the view did load, the view did unload. Should the auto rotation, another method here, should auto rotate to interface orientation, should you actually be able to move it to horizontal, to vertical positioning. But essentially what we're looking at is nothing too complicated. And the purpose of this example is to demonstrate to you from a programmatically point of view the onload and the unload, essentially. So what we're looking at is the did view memory warning. Was there a memory warning? If there was, do something. if there wasn't a memory warning, continue. The view did load and the view did unload methods, which are nothing more than setting parameters for the view itself. So on the view did load, then we have the map type set to satellite, which is from the Earth. So it's the biggest view we can actually get of the world in terms of the correspondence. And then the type is just standard. So if we wanted to, in particular, if we had the view did load, on the load we could actually set a longitude, latitude, location, and actually zoom in and set parameters in terms of, well, when we load the map, what do we want it to see, kind of thing. So set it to a certain house, set it to a certain location, do something to it that's going to be in particular to the application that we're running. And then on the unload, it releases any retained subviews and main memory that might be associated with it. So it's doing nothing more than setting a self my outlet to nil, which it actually doesn't do, but it should do. Well, it actually is loading a super view did unload on the super did unload to superset everything to nil automatically. So what this is sort of a shortcut method of doing this, actually. So, which theoretically you're supposed to do, because if you set them to nil, and then if there's not enough memory, and maps for some reason actually have a tendency to cause memory unload and load, because they do take up a lot of memory in terms of cache information that's being downloaded. So this particular example is doing nothing more than demonstrating to you the use of the proper technique for the load, essentially. And then on the unload, what to happen in that particular case. The other example that I will also upload as well is the one that would actually get through the basic web view. And the basic web view is actually less complicated than either the map view as well. And the map view is just nothing more than a map view instead of a web view interface. In fact, the code is identical practically. If we take a look at the XIB file, we see it's a web view. So I mean, that's all we get essentially is this web view that we've got that's taking up the entire parent of the window. If we take a look at the code, what we're looking at is nothing more than overwriting the load to load a web view, to pointing to what we have now is our window to add the subview, and the subview is the view for the web. And so we're just overwriting the basic window, making it the web view, essentially. So we're loading a web view, and then we're doing a deallocate into memory. So this is like the simplest Hello World application. In fact, that's all the code that's being run, essentially. If we take a look at the controller's not really doing anything either. It's basically having you set the orientation, allowing you to switch the orientation, and giving us our view did unload, basically setting that pattern as well, but it's kind of sloppy, wasn't even done. Did it receive a memory warning? If it did, do something. You do this when you create web views and when you create map views only because you want to be able to save state information, and it should be done as a default for views in general. Because if something does unload, when the view loads back up again, you want to make sure it can actually come back to the place where the user left it at. Otherwise, it looks like the view went away and there was a problem with the application. If you came back to a form, as an example, it was a web form you were filling out, you came back to it and the page was reset, you probably thought your order was lost or something at that point. So it's basically made to retain information. The other interesting thing about this one is using a web controller. So the web view controller is going to display here a URL address Google. And you're going to create a URL object, and you're going to use the URL object with an NSURL request. So doing it in two different steps instead of doing it in one. So the request to load the URL. So it's just another way of creating the method call, and then loading the request into the window, and then running in this method. The view did load actually basically doesn't have a method body. It's in there, but it's not implemented. So to show you the effects of this, it's nothing more than a web view, and the web view is loading Google. So if I run it, we have, lo and behold, a screen that should hopefully come up with a web view that has Google inside of it. And you'll see the default as well. There's nothing really set on it. There it is. So if I zoom in a little bit, I see the default information for the Google website that's way up here on the top that you probably can't see very clearly, and it looks like it should actually work. And if I type something in there, it should actually go and work if I have internet access. So basically that was the two examples to show you how the views work in terms of the loading and the unloading and setting the properties for the view controllers that are part of the user interface. Views are used a lot because we have different types of views that all fit into one category called the view. We've seen the image view, today we saw the web view and the map view. It's fairly straightforward. We just change the view type, change the properties that are associated with it, and voila, we have working different functionality that's basically on the same concept. And the view controller does have a life cycle, as you remember, hopefully from the slides I gave you. And the life cycle is important to keep into consideration because that's when we're able to control the view. So we can control the view when it loads, before it gets ready to load, when it loads. While it's running, there's really nothing to do for it. When it unloads, we can clean up garbage and clean up information. But we're primarily interested in the loading part. And then also, when it does unload, when it's garbage collected by the operating system, when it runs low on memory, views are one of the things that are garbage collected. So when it does get deallocated, we keep the information so that we can restore it. Which is essentially the things that you're interested in doing when you're working up this concept. You're going to have a short class because that's all I had with me, and my other one was the wrong file. It was the wrong one. So next week, what we're going to do next week, make sure to assign roster so you can get credit for showing up today. What we're going to do next week is the example I wanted to do today, which I don't have with me, and that one is a calculator program. So we're going to build a calculator program next week, which is the first assignment for this course, because all of your assignments are due on May 1st. And on May 1st, you're going to have 5 assignments that you'll have to turn in. So we're going to walk you through, if you show up next week, you're actually going to get walked through one of them. And if you can get walked through one of them, you can do the rest of them, actually, because they're all based on the same similar concepts. And I hope you guys have your systems configured at this point. I had one person send me an email. This is the troubling one. I had one person send me an email message and ask me if they could do the projects in Java. Do you think that's possible? No. So that's why I'm getting kind of worried about you guys. I'm like, I hope you've started on this stuff. I don't know. What has been going on out here? So I guess I'll find out on May 1st. All right, so we're going to have a short class today then. So I will see you next week. Make sure to sign a roster, get credit for being here.